Mr. Boyda, what
Yes.
assignment is the football one on?
It's on the last assignment, that one, 7.2 practice 2. There's a new one.
On there.
You don't have the football?
He posted it after we.
It's on practice 7.2 PR2.
Yeah, hold on.
Should be.
Oh, I do, it just wouldn't load it.
Oh, okay. All right, so you do. Good. All right, let's. Come on. Okay, so same kind of deal. We actually did a harder one than this last week at one point. This isn't really that big a deal. We're kicking it from ground level and it's landing at ground level, let's say, right? So what do we need to do with this?
Know that it's a problem.
Yeah, the X and Y.
Yeah, we need the X and Y components, don't we? We know that we're kicking the force acting on the football. There's only one force acting. Excuse me, there's only, let me say that again. Once it's in the air, there's only one force acting on the football.
Gravity.
It's gravity. It acts straight down, right? But we need to know, we need to be able to break this thing up into X and Y components. So as it leaves the person's foot, it's leaving with an initial velocity of 22.7 meters per second at 40.3 degrees, right? So what must I do with that initial velocity vector?
Solve for something.
Well, I'm gonna, remember, the whole point here, when we do projectile motion problems, our strategy is to break it up into horizontal and vertical components because gravity, the acceleration of gravity is strictly vertical, right?
Right.
So that's not horizontal or vertical. What do I probably need to do?
Make it horizontal.
Well, I need to find the components that are horizontal and vertical, right?
Right.
So we could break this up into what we might call V naught sub x and V naught sub y, right? Okay, Lucas, what is going to be, if the magnitude is 22.7 of this vector, what is V naught sub x gonna be? That's 22.7. I want that component. Yeah, but which one is it gonna be? You always multiply the vector times sine or cosine, so you tell me which one it's gonna be. This is the angle right here. Cosine, yeah, because it deals with adjacent, doesn't it? SOHCAHTOA tells us cosine goes with adjacent. So 22.7 cosine of 40.3 degrees. Okay, so then we can set up our columns here. So horizontally, and what else can you tell me, Ellie, what can you tell me about the horizontal component of velocity during a projectile motion problem? Something really important about it. The horizontal component. What's the only force acting on the football while it's in free fall? And that acts vertically, right?
Oh,
Yeah, so the horizontal component of velocity, what can you tell me about it? What do you think? No? It's constant, that's it, yeah, it's constant, right? That's what's important here, because that's one of the things that makes this really easy, because the acceleration is all vertical, it has no effect on the horizontal motion, right? So we don't even really need to call that V naught, right? We could just call it V sub x. That, you see that's a little difference, but it's kind of an important one, it never changes. You could even, if you want to, put a bar over the top, but we know that that's gonna be the number 22.7 cosine of 40.3 degrees. Whatever our calculator tells us it is, that's the horizontal component.
so it's V final and V initial.
Yeah, right, it never changes. Right. Okay, so what about, and what could we, I guess, say about our initial x position?
0.
0. Okay. In the y column, v naught sub y is going to be what?
0.
22.
Not this time though, right? Like with the ball rolling off, a lot of the ones actually every problem we did prior to this one, I think it was 0. But in this problem set, all of a sudden, the projectiles are being launched at an angle.
So like 22.
Sine, good, okay, so it's gonna be the vertical component, that's the leg of the right triangle that we create from the components of the vector that's opposite the angle. We know from SOHCAHTOA
I did.
that opposite over hypotenuse is sine, right? So 22.7 sine 40.3 degrees. Okay, what is the initial value of y?
0.
0. Okay, here's where we got to make some decisions. Now we can do this two ways, but we sort of talked about this last section. We talked about how we deal with, like we did an example, I can't remember what the specifics were, but I think we threw a baseball up in the air and we had to predict how long it took to come, like to get to its highest point, and then how long it took to come back to your hand, that kind of thing, right? So, well, maybe, yeah, a couple chapters ago. So, what was the trick we did with that made it a little bit easier? This was back with kinematics.
Did we break it in half?
We did. Good, we broke it in half, and there's a reason for that. Why did we break it in half?
There's 2 different.
The up is the same as the down.
The up is the same as the down, and so it's symmetrical, but it was really easy to watch. Something unique happens at the top of the trajectory. Velocity 0, right, okay. Now look at the questions that were being asked here. We want to know the football has a hang time of, that's just the total time it's in the air, right? The football travels a distance of, well, that's going to be, the distance it travels during the entire time it's in the air. But look at number 3. The football reaches a maximum height of, you fill in the blank, right? Now that's going to be, when is the maximum height going to occur?
When it's 0.
When the velocity is 0, when the vertical component of velocity is 0, and that's going to be halfway through the journey, isn't it?
Yes.
Right? And so really, being as we're being asked this question, and it's one that you're going to get asked all the time with projectile motion, doesn't it make sense to take advantage of that trick? Right? And we'll just ask ourselves, okay, we're going to kind of break this into pieces, and we're going to say that v sub, I usually just call it like v sub 1/2, meaning the halfway point. What's the vertical component of velocity going to be? Clancy, what's it going to be?
Halfway of that, is it 0?
0, right, because that's vertically speaking. Remember, we always, and you can't lose sight of this, when you break projectile motion up into components, the vertical component is the very same thing as just throwing the ball up in the air and catching it, but that's riding piggyback on the horizontal component, which is just constant velocity, right? So you put those two together, and instead of the ball just going up and coming down, it's going up and moving sideways at the same time, right? But the vertical component is just the up and down by itself, right?
Right.
Okay, so this is something we're trying to find. Or actually, we know that's 0. We're trying to find the time that goes with that, aren't
Yes.
we? Right? Because if we had the time that went with this,
Then no, we just won't.
actually, hang on a second, we even need the time.
Yeah, we use the hang time.
Okay, yeah, we might as well. We'll get the time because then we'll double it to get the total time. We wouldn't actually have to, but we'll get the time. So we want to find t sub 1/2, we're going to fill that in, and then we want to know how high it goes, right? So we know that y naught is 0. What did it say there? We want to know what y sub 1/2 is, right? That's going to be the maximum height. Agreed? Okay.
It's y sub final is 0 too, right?
Is going to be 0. Yeah, that's when it's back to the ground. Yeah, very good. Okay, so then here's all the stuff. Here's all the stuff that we're going to try to fill in these blanks. Oh, we also, of course, know what's the acceleration.
9.8.
Yeah, negative 9.8. Okay. So now, which kinematic equation are we going to use to solve for? We could solve for t. We could solve for v directly, using the one that doesn't have a t, right?
You could do t for
Okay. Or we could solve for t first, doesn't matter. We could solve for t first if we want to, and then plug that back in to another kinematic equation to get the height. Okay? So if we wanted to solve for t, what would probably be the easiest one to use there? Yeah, just be the big mama, right? We're gonna have, so in this case, it's gonna look like y sub 1/2 equals y sub 0 plus v sub, should say vy sub 1/2, right? Does that 1/2 mess you up? You know what I'm saying by that when I do that?
It's when it's.
You could also, sometimes you put an a there for apex.
Yes, I'm happy.
Times t 1/2, right? Plus 1/2 a sub y t sub 1/2 squared. Okay. This is 0. Okay, that's what we're trying to find. All this other stuff we can plug in. Oh, hang on.
No, isn't B
Uh,
sub Y
oh,
1/2
whoops,
0?
hang on, I messed up. Oh, never mind. We don't have to use that hard one. What am I doing?
Yeah.
I don't know.
That's what I was wondering.
Yes, I can see why you were wondering that. We don't have to use that hard equation. What equation do we use?
Use it for the short one.
Plus 18.
Say it again? No, which one can you use? There you go. V equals V naught plus AT, right?
That's what I just said.
Right?
She forgot the first part.
Oh, it is?
Yes.
Oh, I thought you said D. I heard D.
No.
Oh. And that probably used all your available energy
Yes.
to say that sentence, so that was cruel of me.
Yes.
Okay. So V, so
At
V
least I was
final
right.
is gonna be V 1/2.
I think that's the first time I've ever said anything
Equals-
awesome and right.
No, it's not.
Yes, it is.
There might be. You'll get one.
Plus A sub Y times T sub 1/2. That's our equation, right?
No. Wait,
No.
hang on a second. Where did I get the void from? Okay, I got it.
And we know that's 0. That's the velocity at the 1/2 point when we're at the top is 0. All this other stuff, those are numbers. So T sub 1/2 equals minus V naught sub Y over A sub Y, which is, if we plug all that in,
Wait, would it have to be negative a sub y too?
well, A sub Y is negative.
Do we do
Oh,
that in
right.
negative, or do we kind of leave it out?
Say it again.
Do we use the negative, like?
You don't have to.
Okay.
I mean, being as you realize that it's negative over negative, yeah, you can take a shortcut. That's fine. I mean, technically, this is what it is, but.
So we can't do it.
So we're gonna get negative 22.7 cosine 40.3 degrees over negative 9.8, and our trusty calculator will tell us what that is.
Now it's awesome.
It should be. Because the time is only gonna be positive, right?
Yep.
Think what we're after here. We're just trying to figure out, vertically speaking, we just wanna know how long, what's the half time, not the full
Oh, wait,
time. The
wait.
half time is when it's at the top of its, okay, 1.50.
Okay.
Does that make sense?
Yeah, I can use that.
No, I wrote it wrong.
I don't think it's on. Should it be?
Sure, it's not.
Click the on button. On your calculator.
It's always on.
Yeah. Yes, you're right, it's on.
Just do it. Just do it. Just click the on button.
Because we said,
Press on.
good, now
Press
that we
enter.
pressed on, let's press 7.
What is this doing?
Press enter. Mr. Oya, isn't it supposed to be signed? Tanner and that's it.
Don't you have to hit the on button?
No, we already tried that.
Turn it off. Do second on, and then click on.
I think they are. My virtual batteries are dead. What is going on? Well, I know, but I'd like to have that number up here to use.
Give them the involuntary number.
Wait, you don't have to have the number.
Restore default state. Let's do that.
8, 5, 6, 3, 2, 6.
Now turn it on. Oh, it's still on
I'm
3.
just gonna use some random.
It's trying to compute.
Maybe restart it.
You're gonna have like a million threes.
Okay, let's try that.
Yeah, close it out.
Yeah, good. So now we can plug into our equation for vertical position for y. And what's that going to be? Y equals, and this is just going to be the big daddy, right? So y equals y naught plus v naught sub y times t1 half plus 1/2 a sub y t1 half squared. And we know all those numbers. We'll just plug it in the calculator. Okay, so the initial position, that's 0, right?
Yes.
Okay, the initial velocity in the y direction is that. Okay, times 1.5 times that. Okay, and you kind of get used to what's half of 9.8? 4.9, and it's negative. So you kind of after a while just know that that's just minus 4.9 times. Now I got to get that time. There's my half time.
Wait, you times 222.7 sine 40.3 by half. Okay, never mind.
Yeah, that number exactly.
Yeah.
Yeah. Well, what now?
She's just talking about what we were just talking about, the acceleration with multiplying it by 1/2.
Oh, okay, there you go. Gotcha. Okay. And that's our answer. So rounded to 3 places, 11.0.
That's the distance?
So that's the hang time, yeah. So the football reaches a height of 11.0 meters. And the total distance it travels is going to be pretty easy, right? Because that's just going to use the equation v sub x equals v sub x t, right? Same thing as saying, technically it's this. Technically it's x equals x naught plus v bar sub x t. But the average velocity is just the velocity, it stays the same. Initial position is 0. So it's just that,
Okay,
right?
so
Just velocity times time.
Hey, Braden, what's that number?
the 11.0 you got from doing the 22.7 sine 40.3 times.
Right, exactly. I got from this equation right here from plugging the numbers in. So that was 0 plus whatever that
42.7.
sine 40, whatever that number was, times t, which we'd already found was 1.5 rounded, plus 1/2 times negative 9.8 times whatever t was squared. Yeah, exactly. Okay, so then for this other part, we're just gonna, for the solving for x, we just get v sub x, which is 22.7 cosine 40.3 times the full time, which is that one, right?
Oh, the full time?
Yeah, because you see why? Because now we want to know how far does the football travel? Well, it's going to travel the horizontal distance, entire horizontal distance over the entire time it's in the air.
And what was our entire time again?
It was rounded to
Almost
3.00, but here's what it was with lots of digits.
Yeah.
So the answer is 51.9 meters.
I feel like they didn't kick it that far.
Yeah, that's not super far.
It's half the football, it's like half the football
Yeah.
field.
The NFL
It's-
is fire.
Well, yeah. Okay, it's not far for an NFL kicker.
Well, yeah.
Probably pretty far for us, yeah.
I kicked something.
So should we go try those? Just to make sure we did it right?
Down the field?
We have 3 minutes
Okay,
That looks like a 5.
preview. All right, so the first one we said was 3 seconds. Second one was 51.9 meters. Third one was 11 meters. Moment of truth. How'd we do? We got them right. What do you know?
I'm shocked.
Or Mr. Way